So if you see people walking out, we aren't taking it personally. We know in advance. And then you may see people coming in a little bit later because they had morning activities. So we are flexible, and we are just grateful that you took time to share with your experiences with us. Now, right now, Earl will do the prayer.
Everyone bow your heads. Loving Heavenly Father, we come to you this hour and ask for your blessings and help as we gather. We pray for guidance in the matters at hand and ask that you would clearly show us how to conduct our work with a spirit of joy and enthusiasm. Give us the desire to find ways to excel in our work. Help us to come together and encourage each other in excellence. We ask that we challenge each other to reach higher and farther to be the best we can be. Amen.
Now, our first speaker has to leave quickly. So, Cynthia Black? Okay. Let's welcome Cynthia Black, please.
Thank you so much. I appreciate you all for giving this opportunity to myself and all the panelists here. I'm looking forward to hopefully inspiring and waking up something amazing in each of you, because you already have what it takes to be amazing. So I just pray that you guys lean into that. So how did I get here? Inspiration, drive, momentum, and milestones. All right, now let me get this right. Oh, okay. Highlights. My name is Cynthia Black. What is the name of my employer? I work with the federal government for over 30 years. What is my career title? Information technology specialist, cybersecurity. Right now, I have done software engineering, system engineering. I was a math teacher in former life, as well as technical management. We'll talk a little bit about that going forward. What type of education is needed for your career? Bachelor's of Science, having an advanced degree is a plus, as well as a security clearance. How many of you understand what a security clearance is? Okay, so two. So a security clearance basically is allowing you, it tells the government that you are trustworthy. So there's a whole bunch of things that play into that, like you can't have a bad background, you can't have a police record, you can't steal, or all the things that they talk about in the Bible, basically. So if you, what they do is they assess and see if you're trustworthy to handle data that is priority data. So if you have classified data and things of that nature, the security clearance has different tiers. Sometimes the secret clearance is the very low tier. Then there's top secret, then there's top secret TSSCI. Usually the companies that you're hired for will have to do a background investigation, and they will have to pay for that. So a security clearance is an additional plus. All right, so describe my typical day. Meetings, planning, executing actions, reassessing risks, lessons learned, and measuring the impact, and repeating the cycle. I'm gonna take it out of the engineering space for a minute, and I'm gonna put it on a day-to-day space. We're each engineers of our own life, and suppose you wake up and you know that you need to get to work by a certain time. You have to engineer how you're gonna do that. Are you gonna take the freeway, or are you gonna go through the city? And those are the two decisions that you're gonna have to do in order to engineer your goal of getting to work on time. So if you go through the city, you might run into some challenges like traffic lights, things of that nature. If you go through on the freeway, you could run into traffic as well. Or you can get in your car and not have gas, and that's another challenge. So all of those things are called risk. And so when you're doing your engineering in our space, in your job, this is the same concept, same logical concept. Think like that. So, what do you love most about your career? Inspiring others who may feel that this field is out of their reach. Most people call it college is not for everybody. I want to do a spin and say that college is not the only way to meet your goal. That's how I feel about that. So college is attainable for everybody.
That's right.
I'll say that slow.
Yeah.
College is attainable for everybody.
Absolutely. That's right.
Okay. All right. So additional information you want to share. Well, I'm going to talk about some things that inspired me. Maybe you'll see some relationship there. We'll go from there. So in 8th grade, I read a book, and I was inspired by a woman called Marva Collins. Does anybody know who Marva Collins is? Have you ever heard of her? Oh, my girl back. Boop, boop, boop. So Marva Collins, I'm going to read this verbatim because I don't want to miss any details. But Marva Collins was a broader education activist and founder of West Preparatory School, whose method focused on strong curriculum in reading, math, English, and the classics, along with high expectations, strict discipline, and nurturing atmosphere. She was known for elevating students from disadvantaged backgrounds by teaching them foundational skills and classic literature, regardless of their initial academic background. So I want to make sure that we get that quote there. Could we push the slide to the side just a little so I can get that quote? Because this is important. Sorry. Oh, great. Kids do not fail. Teachers fail. School systems fail. The people who teach children, they are failures. They are the problem. That was Marva Collins back from 1936 to 2015. So her ideals, after reading her book, I was totally inspired. I used to stutter. I used to have trouble with comprehending. I used to struggle with speaking in front of you guys. Can you imagine? And I read her book, and I was like, oh, I can be a teacher. Oh, she gets me because she thinks outside of the box. That's right. The teachers are there to inspire you. And if they don't, find other mentors that will inspire you because it's not you. All right, so I'm going to go ahead and leave that there. All right, so the drive. I was the first one in my family to complete college. My mother.
I'm sorry, I think that's cool.
Thank you. My mother, Diane, encouraged me to get smart about this thing called this computer stuff. My mother never went to college. She, was like, I don't know what this computer stuff is, but you better get smart about it. So I got my master's in technical management from Johns Hopkins University, Whiting School of Engineering, bachelor's of science, dual degree in math and computer science from Virginia Union University. I initially went to Virginia Union University. I wanted to be a math teacher, and my mother told me to get smart about computer science. I skinned the cat both ways. I said I'll do a degree in math and computer science. Experience over 28 years, career spanning from math instructor, computer instructor, software engineer, computer scientist, system engineer, technical manager, and now a cybersecurity information technologist. We'll just go ahead, and this is from the young lady who used to stutter and didn't understand and couldn't comprehend certain stuff. Boom. So the momentum. Everybody knows momentum is something that keeps you going, right? So relatable mentors along my journey from all aspects of my life. Every experience is a building block. So with mentorship guidance, look for that in your workplace. Thoughtful leadership, look for that in your church family. Look for that in good friends. Surround yourself with a good set of friends. And let's be clear, friends that are in church are not always the ones. You have to lean on God and ask God for guidance and to send the right people your way and pay attention and make sure that you listen to them. Advocacy and activism. Be involved in organizations. I'm involved in several organizations. I'm in the Continental Society. We give back to underserved students in the community. I'm a member of Alpha Kappa Alpha Sorority Incorporated. And we do a lot of things in our community. I'm a member of National Society of Black Engineers. And we also, do a lot of hands-on things with students in the STEM space. I volunteer to tutor. Just always continue to give back because it will come back to you twofold. Milestones. At every milestone of your life, own your gift. Know you are relevant. Embrace challenges as they sharpen your craft. Welcome criticism as you are the most unique you there are, okay? So you know what's going on. You're meant to be there. When you get your education and you land your job, you're meant to be there. Listen to your own organic feelings and understanding of what you think needs to happen. That's how you start. And then you've already been trained, so you got this. Questions? Thank you for your time.
Thank you so much. Thank you so much for sharing that information. Now we'll have Dr. Kelsey Gray. He has to leave early.
Good afternoon, everyone. All right. I want to give a thank you to Janet and Rising Sun. I want to give a thank you to Janet and Rising Sun Baptist Church in Nesby for allowing me to be here. My name is Dr. Kelsey Gray, and I am a postdoctoral research fellow, ORAL. Explain what that is. Basically, when you finish your PhD, you can go into industry, consulting, academia, government. There's a lot of pathways you can do. It's not just research. But when you finish that training after 5, 6, 7, 8 years, after that long time being in school, you still don't know enough to be technically successful. So to usually get involved into a postdoctoral, which is basically just extra training, and they pay you a pretty decent sum of money. It's great. It's great. So, and you have lots of freedom. And basically, you end up getting there by, like I said, by doing a PhD, which is free. And I'm not sure if people know that, but a PhD is free, and they pay you money to get a PhD. And it can take anywhere from 3 years. A PhD is free, and a PhD is free, and you can it can take anywhere from 3 years to about as long as God says so to finish that degree, and they pay you anywhere from $30,000 up, depending on where you live. And thankfully, we're blessed to be in an area where we have several excellent post PhD programs, graduate school programs. So you got Morgan, you have UMBC, which has a very well known, that's my alma mater, which has the Meyerhoff program, which provides a ton of support and guidance that with a community full of grad students who look just like you, to teach you how to be successful, not only academically, but professionally, and give you that community support that you never know that you really need, because when you go away to college, it can be isolating, but you feel recharged and energized when you're in a room that looks like you.
That's facts.
So basically, how I got the way my journey started off was I went to school to play basketball, and I got hurt my third year, and I was devastated because I thought I was going to go overseas and make that happen, but God had other plans in me. So I ended up transitioning from that school to another school where I fell in love with research. How I got involved with research is in high school, which is why I emphasize you take as many classes as you can. I was introduced to this one professor who did a TED talk on synthetic biology. And long story short, what synthetic biology is, it's the same way you can code programs to make apps and software, you can do that for living organisms. So you can code and program bacteria, fungi, which is what I work with, to do certain applications. So for example, in my day-to-day, what I do is I work for the Army Research Lab, and I will engineer fungi to make melanin. And melanin has a ton of stuff that I cannot talk about, but it does a lot of really awesome things, in short, for protection, armor, energy. Put like this, a gram of gold is worth $100, a gram of melanin is worth 500. So, yeah, that's one of the many reasons, and it has to do a lot of things with, let's see, defense, the intelligence warfare. That's the one word I can describe it as, intelligence warfare. So Google that term, and melanin plays a huge role in what you can do with that. Also for my work, I also make materials out of fungi. So those are called mycelial materials, which are basically, you can make clothing, you can make houses, you can make surfboards, you can make electronics to house, yeah, the fungi is sort of like the chastity, or the armor that is, or like the plastic that can house these electronics, and I work with that as well, all by engineering fungi. So by playing with different genes, which are sort of the traits that are found in these living organisms, I can completely remove certain genes or overexpress and turn them on, make them go really, really fast, to get certain phenotypes or properties that will allow them to make more melanin, produce certain types of melanin, make them stronger, make them more elastic. So, yeah, I feel like I'm jumping around a little bit. But basically, back from my story, I got injured. God took me another place, another school, where I was able to do research on this professor who I first saw in high school through this TED Talk that I was introduced to. And I walked around everywhere to try to find this professor, and I was very, very intentional and adamant about joining this professor's lab and asked if I can join their research lab. Unfortunately, he was away in Africa when I found out, so I ended up talking to his grad students, and they let me in the lab, and through that time, I was able to just learn how to do research. I didn't know how to do anything. This is my technically my fourth year of undergrad, so I'm kind of behind the 8 ball here, but favor is not fair, and God allowed me to have this supernatural acceleration to be able to just learn how to do science in a relatively short time. So I had a great mentor who just poured into me, and through that, he told me I was going to get a PhD, which was not in the plan to me, because when my original plan was to be a biotech CEO, and my mentor told me that, long story short, there are 3 ways for you to do that. Get an MS MBA, you either get a PhD or MD. Hated med school. PhD I thought was going to be too long, and so I thought MS MBA. Told my mentor that, and he said, you're not going to do that, because a PhD has so much freedom where you can do limitless things. If you want to ask me more about that, I'll be happy to talk, give you my information. But yeah, PhDs, so I trusted him, prayed on it, and I pursued that. So that's what led me to this journey here that's what led me down to Maryland when I moved down from South Jersey. And that's what brought me to UMBC to get my PhD, and what allowed me to become a ORAL postdoctoral fellow, which is at the Army Research Lab. So basically my day-to-day is, when I go into the Army Research Lab, is I'll check my email, I'll plan out my experiments, I'll get ready for my meetings, and then I'll have to do my experiments and do some writing, because you have to be able to communicate your science, right? You want to make it interesting. The audience I'm talking to is not a whole bunch of other scientists. It's not an incubator. I'm talking to generals, lieutenants, people, soldiers in the Army. So I have to make sure that my science is not only interesting, but make sure it matters. Because if I'm talking about fungi, who cares, right? I have to talk to you. I have to convey that my findings in ways that soldiers care about. So how's it going to make them more lethal? How's it going to make them be able to survive in different conditions? How's it going to make their life easier? So I have to sort of relate my findings in writing or in a presentation. And afterwards, I have to package all those work together to try to form a story. Because when you're able to tell a story, people are able to connect with your science and your findings and make people care. So one thing I love about working for the Army Research Lab and doing ORAL is I can chase my wildest dreams and do whatever I imagine. The privilege of working for government, outside of what's going on right now, is that If you're a contractor, you still get paid, which is great. So keep that in mind if you look between civilian and contractor. But is that with government, money is not a, when it comes to research, money is not a limitation. You can, things that might be challenges in other settings, such as industry, where you're focused on the profit or bottom line, or academia, where you might not have that luxury of having an abundance of money. Government, you can buy whatever you want to get this experiment done and do whatever you imagine, and that is a freedom that that I didn't appreciate until I got to where I was at. And everything sci-fi, so Star Wars, that's very real. So things that you think may not be real are very real that they're doing in the government. Preparing the Army of 2050, that's the Army mission, and it's awesome. It's awesome. Also, I'm not here under any official capacity of the Army, just for the record, just to make sure that's very clear. Yeah. So I am a ORAL postdoctoral fellow. So, and the seventh thing, what was the what do you love about? What was the seventh? It was the seventh.
Was it Day in the Life? Information about career opportunities at your organization and how students can prepare for them.
Oh, yes. Information about yeah. So one way to get involved, join NSBE. Just get involved in NSBE, and that's one way of being. Is when you have a community of people who look like you, understand, who've done it, and understand the challenges of how different it is, or just the challenge of being an engineer in general. It's easy for you to get that one-on-one mentorship, that connection, and to get that guidance you need. Yes. So the NSBE stands for National Society of Black Engineers. So there's a high school chapter, there's a NSBE Junior, there's the Baltimore chapter was just resurrected. So yes, please connect. Other ways to get involved. Army Research Lab has a partnership with all local HBCUs, so Bowie, Morgan State, Coppin. There's also Army Research Lab is right across the street from University of Maryland. There's all kinds of programs. You just have to get connected with those institutions. Send an email to the outreach office. You can also talk to me. Again, my name is Kelsey Gray. You can find me on social media, LinkedIn. My email is kelseygg2. So my name, Kelsey, G2 @umbc.edu.
Can you
Yeah.
spell that? Is it
KELSEYG2
okay? Got it.
@umbc.edu.
Cool.
And yeah, that's my time. Does anybody have any questions?
Thank you so much. All right. Judith Carroll has to leave early.
Check. Be close.
I have enough voice I could fill the room without it, but I'll do it. So my presentation is just a little bit different. 1 minute on me. My name is Judith Carroll. I grew up here in Baltimore County. I went to Northeastern University, and I'm a civil engineer, and I work in the construction industry, so it's very different from what you've seen so far. And in point of fact, I'm probably the least educated of the speakers that you've heard so far.
I doubt that very much.
I have a bachelor's degree in civil engineering. And I went to Northeastern University up in Boston, and one of the reasons I chose Northeastern was because at the time, and this was way long ago, they had a co-op program. Many colleges now have co-op programs. And what this allows you to do as a student is to work, in my case, in an engineering office, so that you could get a feel for what's going on. You didn't have to look for your job. The university has arrangements with various employers. So you could spend a co-op semester working for a civil engineer, a co-op semester working for a mechanical engineer, a co-op semester working in biomedical. Point being, it can show you what you're interested in. It can show you what you're not interested in. And in my case, it can help you pay your tuition. So, because I have 7 younger siblings, and my father said, I'll pay your first year. After that, you're on your own. So, and many schools, including University of Maryland, have excellent co-op programs now. So the company, I am the president and principal stockholder of Carroll Engineering Incorporated. We're located up in Hunt Valley. We've been in business since the mid-'60s, and I've been at the head of it since 1983. How I came to be at the head of it was on the untimely heart attack passing of my father at the age of 49. I was 25 years old, right? So everyone here is going to talk about mentorship. Mentorship is huge and has been hugely critical in my life. There's something to be learned from everyone. Everybody does something really well. Find that one thing and feed on that. Ask questions. Don't ever be afraid to ask questions. Don't be afraid to say, hey, tell me about this, or how did you do that? So that's extremely important. I had mentors in accounting. I had mentors in the law. I had mentors in engineering. I mean, across the board, everything. So they're very, very important. Some of the things that we do, as I said, we are civil and structural engineers. So structural engineers are the bones of a building. You walk by or drive by a building and you see the steel frame or the concrete, and we'll look at some pictures. That's what the structural engineers do. The civil engineers do land planning. They do site development, how the water gets away from the building. They're very environmental civil engineers, how to control stormwater, how to deal with it, how to treat it and clean it before it goes into the system, how to protect the Chesapeake Bay. So all of that is part of civil engineering. Incidentally, we also do some landscape architecture. So if you have a more artistic bent, then landscape architecture might be your thing. I personally have a black thumb, so that's not my thing. So we have in our company have worked on a lot of different types of projects, and we work on a little bit of everything. So people say, what's your niche? Architects have a niche. You may be a hospital designer, or you may be a school designer, but the steel and the concrete in the building is the steel and the concrete in the building. The ground, the grades, the stormwater, doesn't matter what you're dealing with, it's that, okay? So we do a lot of different types of things in our business. This is just one example, and these are some of the more fun ones, right? Do you recognize this? What is it? Oriole Park. It's the upper deck at Oriole, upper bar deck, whatever that is, at Oriole Park. We did the structural work for that. And so it's a lot of fun. We've done a lot of work at Oriole Park and at Camden Yard. You should, did anybody recognize this one? If you're looking at colleges. This is Morgan State University. Yeah. There you go. Well, that's the new Student Services Building, Calvin and Tina Tyler Hall. Yep, on Cold Spring Hill. That was a fun project because it was a project where they took down an old library and then put up this new building. There's a lot of grade on this site. It runs probably from the street elevation at Hillen. It probably goes up 60 feet at the back side of the site. So how do you get from here to there? And how do you get from here to there if you're not able-bodied? If you have to accommodate the Maryland with Disabilities, the Americans with Disabilities Act, that's part of what we do. You keep going. That's one of the ways to do it. A whole lot of ramps. A whole lot of ramps, a whole lot of landscaping. What you see over there on the right-hand side in that little triangular area, that's stormwater management. So stormwater management these days can look very nice. It's certain plants, certain materials, and underneath all that is a special kind of dirt. It's a filter material that all the stormwater goes into. One more. Oh, this is Baybrook Elementary School, something similar. The challenge of this one was to keep the school in operation while we built the new school, and then to transfer all the student body over. What do you do with all the parking, right, when you make the transfer? So it's a puzzle. So I'm going to tell you something. a lot of times people ask me, do you have to be really smart at math to be an engineer? What do you think? No, you don't. I was a decent student in school. In high school, I was a great student, but I was a good student in school. What you really have to do for engineering is like to solve puzzles. Everything we do is a puzzle. How to put the building together. Site work like that, like you saw before, is a three-dimensional puzzle. It's really how you put together puzzles. I'm going to tell you something. When I went to high school, I aced pretty much everything in high school without cracking the binding of a book. No problem, right? I thought I was a genius. I went to freshman year at college. I still thought I was a genius. Right? I got to sophomore year in college. Now all of a sudden I'm looking at stuff I've never seen before, and my grade point average went right down the tubes because I had no study skills. I didn't know how to study. So if you think you're smart and you don't have to study, learn how, because I'm going to tell you it's going to hurt if you don't. So anyway, this is Baybrook Elementary School, and it was a brand new school in Baltimore City. Turned out very nicely. This is the back end of it, so the landscape architects deal with how everything looks, the playground, the fancy fencing, all the equipment, how to put the playgrounds together as per the age of the students. So all of this is all part of the site design that we work on. Next one, please. More fun stuff, right? So Ravens Walk was largely a stormwater effort and a landscape architectural effort. But it's kind of a fun project because you get to work down at the stadium, you get to meet all the people, you get to go underneath. Next one, please. This is the less glamorous part of it. This is the stormwater part of it. How to take all the water off these giant parking lots, collect it in a spot, treat it, clean it, hold on to it, and release it slowly into the city storm drain system so that the city storm drain system doesn't get overloaded. Right? So that's part of what we do, and you can see the size of what we're dealing with here because the parking lots there are huge. But you don't see it now when you walk there. All you see are some manhole covers because it's all underground. Next one, please. Yes, more fun, right? We all know Ray Lewis, right? So we worked on the stadium on Unitas Plaza. I still call it Unitas Plaza because I'm old. So we worked on Unitas Plaza when they redeveloped it, repaved it, put the Ray Lewis statue in, so that was kind of fun. We're still doing work right now at M&T Bank, M&T Bank Stadium, because they're doing a whole bunch of renovations to make it more of a destination, right? And they're going to be doing the same thing at Oriole Park, and we'll be working on that as well. So sometimes you get to do kind of fun stuff. Next one, please. This is Eager Park. This is more of a civil engineering landscape architecture effort, right? So this is outside of Kennedy Krieger over in East Baltimore. And it's just a very nice kind of oasis in the middle of the city. Next one, please. Structural and civil. This is, what is this? This is a Penrose development, Renaissance Row over in the Pimlico area, right? So we did the structural work for that, and we did the site engineering work for that. So the structural work is about figuring out how much the building weighs, how much the building needs to, how much wind blows on the building, how to keep everything upright, how to keep everything stable. Next, please. Oh, this is back to our little friends. We're out of order. This is back to our little friend at Morgan State. All those things that you see there are stormwater management devices. See the big pipe with the rock coming out of the one on the right side? Right? So stormwater flows into there. At that level, it goes down through the dirt, gets cleaned through the dirt, flows out through the bottom. Right? So if you're I have a couple of environmental engineers that work for me. They're very big into the stormwater treatment, water management, that sort of thing. Next one. Structural. This is, so I started my career as a structural engineer because our company did only structural engineering when my dad had it. When I took over, we took on civil engineering just as well. This is over in Owings Mills. There's also a completed picture of this. I'm not sure if it's next or not, but what you're looking at here is a concrete, what they call flat plate building. So the floors are concrete, the columns are concrete, everything's concrete. The wood that you see there is supports to keep the concrete in place while it's getting hard. It's a thermochemical reaction in concrete, right? When you put the water and the cement and everything together, it develops heat and it hardens up. So that's what you're seeing here. And that over time, they'll take all that out and you'll have a nice concrete structure. Next one, please. Yep, there it is. That's it, finished. And I'm going to tell you, as a young engineer, it's very interesting and a very cool feeling to ride by something and say, yeah, we worked on that. We did that. We designed that. And guess what? It's still standing there. So that's pretty cool. Next one, please. This is Schilling Green over in Hunt Valley, not too far from our office. We're not in that high rent district, but it's not too far from us. They were interesting because they were old buildings, and Merit Properties owns them. They pulled everything out of the building. They pulled the skin off, left a steel frame, and said, okay, now make it look brand new and make it operate brand new. And it's not only did we do that, but these buildings are also leadership in environmental and energy design or something like that. But anyway, it's a measurement of how energy efficient this building can be, right? So, and you could be LEED certified, silver, gold, platinum. There's various levels depending on how energy efficient you want to be. But so these are LEED buildings as well. Next, please. There it is when it's stripped down. Right, so that was all stripped out, nothing there. There was a new roof put on the one side of it, and so we used the old skeleton of the building, which was perfectly fine. There was nothing wrong with it, and made a brand new building out of it. Next. What is this is National Harbor. We did a bunch of the buildings down in National Harbor, and that was very interesting because the foundations are different because you're so close to the water. Right, your foundations, what your building is resting on in the ground has to go down very deep because the water is so close there. But that was a fun project to work on. We worked on that one in the structural side of our house. Next. Keep going. That's Schilling again. I don't know are we going backwards? We're going backwards. That's the end? Oh, okay. All right. So that's a little bit about what we do, about what, civil and structural engineers do. Do I love it? I love it. Why did I get into it? Because my father used to take me around and show me things, and I was fascinated by how things went together, right? So some people are fascinated by how engines and parts go together. Some are fascinated by how buildings and plans go together. I was just fascinated by how things go together. And I spent a summer working in his office, and I thought it was very interesting. I thought I had some plans in that slide deck, but so we are basically the ones who draw the plans. We run the numbers, do the design, draw the plans. The plans go to the contractor. The contractor builds from the plans. Sounds very seamless. It never really is. But you know what? I bet it's those PDFs that didn't show up, but that's okay. No big deal. So that's a little bit about what we do. I think I realized I wanted to be a civil engineer when I got an opportunity to work some co-op and to work in some civil engineering office and see what they do. And there's all different branches of civil engineering. One of the things that we don't do that a lot of people do is bridges. Bridges are not my thing, but they're interesting, and a lot of the big companies in the Baltimore area do work on bridges. Some of them will be working on the reconstruction of the Key Bridge if that ever gets done. It's going to happen. People ask me about that all the time. When is that going to be rebuilt? I said they have 2 years of permitting to get through first. Yikes. You don't just build a bridge. You don't just work in the Chesapeake Bay. You don't just work around the Chesapeake Bay. One of the things that we do is get involved in all those pieces so that when this bridge or anything finally gets built, it has no harmful effect or minimal harmful effect on the environment. I got a couple of projects right now where we're working with the Maryland Department of the Environment to create some streamways and move some streamways, but it's a long and involved process. And when you're working on the bay, you're also working with the Corps of Engineers. So it's pretty onerous. But anyway, Does anybody have any? I know I don't have a whole lot to more. Oh, there you go. So that's a copy of a structural plan that we worked on. And what you're seeing there is the sizes of the beams and the columns. That's a steel framing plan that our structural department would work on and would put together. Generally, they work in three-dimensional models, and then they can export them to these flat plans that the contractors can use. And then I thought was there one more? Yes, I will. Yes, ma'am. Mm-hmm. Not for us, because our work is already fairly prescribed, but meteorologists do work in the environmental industry. So the answer is yes, but we're not. They're more going to be on the research side, and in the side that's developing the regulatory environment. But we're more on the design side, so they wouldn't necessarily work in my office. Okay. Well, no, they work. I'll give you a quick rundown. What's the difference between the civil engineer and the architect? The architect is, first of all, he has knowledge of all the trades. Architects have to know a little bit about mechanical, electrical, civil, structural, all of that. Their testing, their licensure testing involves some of all of that, not as in-depth as those individuals, but some of that. So the architect deals not only with how the building works, not how the building looks, but how the building functions, right? How spaces get oriented so that this office, which needs to communicate with that office, isn't constantly running down the hall. How to deal with the codes. If there's a fire in the event of an emergency, how do people get out of the building and how do they do it quickly? So the architect works with not only how the building looks, but everything about how the building functions, outside and inside. Does that make sense? Mm-hmm. Yes, ma'am. So we hire people with engineering or landscape architectural degrees, although we do also take interns. So I've hired interns over the summer from high school, latter years of high school, and interns in college. But by and large, the people that work for us are degreed engineers or computer operators, such as CAD operators or building information systems, BIM operators. So those are not necessarily degreed engineers, but they are experts at producing these kinds of documents that you see. This is a site document. All those squiggly lines you see are grades. Everything represents a foot change in elevation. So those are some of the documents that we create.
You got a question behind you, actually.
Yes. Okay. So what's the deciding factor for whether to demo a building or reuse the frame? First of all, the condition of the frame. Second of all, the use of the building, and will the frame be conducive to the use of that building? If you've got a frame that has very narrow spacing of the vertical supports, the columns, but you need big wide spaces, that's not going to be helpful. The age of a building, that's also part of it. And the cost. Sometimes it costs more. We're working on a project now for the Army Corps of Engineers. It's going to cost more to bring the existing portion of that building up to Army specifications than it is to knock it down and rebuild it. They're trying to decide what they're going to do. So, yes. So pretty much everything we do now is three-dimensional. All the building work, the structural work is all done in 3 dimensions. And it's all done in the cloud. For the most part, everything is done so that the architects, the structural engineers, the mechanical, the electrical, fire protection, all those people that work in the building are all working on the same model. And they do that so that when the building gets built, there's less of a chance for a pipe and a duct trying to operate or occupy the same space. So I think that will just continue to evolve and get better and better. On the civil side, we don't work in this. We work in 3D for most projects, not necessarily in the same system, because the BIM systems aren't designed for site work. But site is a little funky because you might have a really small site in the middle of the city, and you don't really know what's in the ground. So why would you build a three-dimensional model? Because you don't really know what's happening. So it's site, I think, the technology to define what's in the ground without having to dig it all up, I think needs to evolve more and is evolving. And then that will become more of a constant 3D effort. Yes, ma'am. It was called the program I went is called a co-op program, like cooperative education. So if you want to be a mechanical engineer, you find a school that you like, that you can afford, that has a co-op program, and their co-op advisor becomes part of your advisory team at your college. And if you want to start doing some co-oping or some shadowing or some internships now, there's a lot of mechanical engineering firms around that hire interns. Ms. Blunt has my contact information. I can put you in touch with some of them. Mm-hmm. One last, okay. So as engineers and architects, we're not bidding on jobs like a contractor. The contractor has to put a financial bid in. Oftentimes what we have to do, if you've developed a relationship with a private developer, then that's good. But for public work, oftentimes what we have to do is submit qualifications. And then they pick the most qualified, and then you can negotiate a fee. So, but we're not bidding dollars for fees like a contractor would. Thank you all. I appreciate your time.
Here you go.
Okay. Several people mentioned they had to leave early. Anybody else? Okay. Thank you so much. Thank you. Okay. The next presenter will be Earl Lowe. Are you ready? Are you ready? Are you ready? Okay. Do you want to go next? Somebody else to go?
Why not?
Yeah. Okay. Let's just go down this road then.
Okay,
Start right here.
looks like you're up, buddy. I was pulling up my email.
No, it's just one slide in there. You see where it says skip. All right, yes, that's fine. Make it bigger if you want to.
Shift F5.
All right, there we go. Hello, everyone. My name is Sir Walter Richardson. I work for Northrop Grumman. Thank you for centering that. What do I do? So my main title is engineering manager. So what is that? You could break that down in a couple ways. So what what do we work on? Mainly we work on electronics. So you think about your cell phone. Pretty much everyone has one these days. So what makes it work? What makes it work functionally? It's in your pocket. It has to be something small. It has to be able to communicate. You need a battery. You need components that allow you to communicate with a radio tower or a cell phone tower. Right. You need today. You need to be able to run apps. You need to be able to access your Facebook, your Instagram, whatever else you're using, right? Your email. Well, basically, someone has to go and design that, right? So someone has to know how the circuits work. So if you think about your cell phone, you have power, you have a signal, you have something to command, you have something to sense, right? This is not a cell phone, but this is a circuit board. So a lot of things that we produce involve, making a circuit. It's something physical that goes into a larger system. So we have this PCB board. It's unpopulated. No components are on here. When I say components, I mean electronic components. There's capacitors, resistors, different sensors, microcontrollers. These are the words we use when we're trying to develop our system. These are the smallest components of the system that we care about when we're designing a PCB or electronics. What do you need? So if I were looking to hire somebody, I kind of want somebody that has an engineering degree, preferably electrical engineering, but it doesn't have to be. You could be a physics major, or physics, I'll say someone with a physics degree, someone that at least understands the circuits. Circuits, that's kind of like the bread and butter of the electronics world. So if you attend a four-year university, get that degree, want to get that internship experience as well. So how do you get the internship experience? You got to think about it as a system. Start with the goal and kind of work backwards. And I'll talk about the job. Now I'm talking about what else do you need to get to that job? The internship experience. How do you get the internship? Well, be in that major, right? Be in that STEM major. I'll go ahead and break down STEM if you haven't heard about it. Science, technology, engineering, and math. Those are your technical. That's a grouping of technology degrees, right? So when you're looking to find out what type of degree you want to pursue, start out with what type of career you want to work on, right? So, and just work backwards. Okay, so I attended University of Memphis. That's where I'm from, Memphis, Tennessee, very far from here. So I have a bachelor's in electrical engineering and also a master's in it as well. My first real job after completing my master's was at Arconic. Now, they didn't produce electronics. They produced light metals for aerospace and automotive. So you probably see the Tesla or the Ford F-150. Someone has to produce that metal, right? Now, was I going out there and rolling ingots? That's a block of metal. Was I rolling that by hand? No. We had machines to do this, basically robots, to go and make the metal for us. If you want a lighter vehicle, you want to go with a lighter metal. Steel is okay, it's strong, but aluminum was the way to go at the time. So what did I do? Well, someone had to automate those machines. Someone had to tell that robot what to do, okay? Someone had to make it so that a technician, someone that works with engineers, so they could just press a button and get the job done. Press a button, okay, load a coil. Press a button, move the cart. Press a button, chop the metal up. Make it so it's good every single time. Make sure the quality is pure. So with that, someone with a computer science background, that may be the job for them. They want to work in automation. Being able to write the code, look at the code, break it down, make an algorithm so that it produces the same result each and every time. Okay, all right, that brings me to Northrop Grumman. I talked about the electronics. Generally speaking, people talk about hardware, that fills that electronics. Well, you can go into more especially electronics like the RF stuff as well. So that's radio frequency. So that's a signal that's transmitted through the air, right? Your signal that's coming to your phone, it's, you can't see it, but it's there. You need something that can detect it, that can also produce it as well. So you need someone with an RF background to be able to do that. What do I do now? Most of the stuff I do now is engineering management. So that also involves people management, but also project management. So we have these complex devices and machines. This is a this is a stress reliever, but it's a fighter jet. Some of the systems on this fighter jet, like a radar system, which is an RF-based system, you need to have a lot of different systems in place to allow this this type of device to work. So fighter pilots can sense objects out there in the field. The field can be wherever you want it to be, but you want to be able to sense stuff at a range, right? So you can do their mission safely. Hobbies and interests. So I didn't just wake up one day and decide I wanted to be an engineer. That may be true for somebody. But over time, I knew that I wanted to invent stuff. I wanted to make toys. Maybe I wanted to be a toy maker. But as I progressed, I started talking to people and understanding that, hey, there's other goals out there, right? I just happened to have a sister. She was about 10 years older than me. She was in school studying electrical engineering. So after I found out I wanted to be an inventor, I found out that, hey, there's a discipline that seems like all they do is invent stuff. So I pursued electrical engineering. So that's how I got there. Have I invented anything? Probably. Have I invented anything that was worth selling? I don't think so yet. I'm still getting there. So I do work for a company that does invent stuff all the time. So I'm proud to be able to do that. That's interesting. So if you think about it as a total system, you need someone that can design the system, but you also need to know someone that can also operate the system. So taking feedback from someone that has experience already operating radar systems would be helpful. So if someone is working as a radar technician, they know how it operates at least, right? So earlier I mentioned technicians, right? So engineers usually work with technicians. These are your operators that are going to be using the machine. So taking their feedback to make it better, it may be that, an engineer designed 15 buttons to get a system working. Well, it may be that the engineer is never in the field and may not actually see how it's actually going to be used, but that radar technician does, so they can take the feedback from the radar technician that's out there actually using the system and design a better working interface. So yeah, definitely. Next question. Oh, I like that question. Now, that's not my discipline, but I do get into AI outside of work. But yes, there are lots of people at our company that deal with AI, trying to integrate it into the new systems and things like that. Earlier I mentioned automation. It's not well, there's a lot of terminology that's being thrown out there. I worked on automation before I really understood what AI was, but this new AI, computer vision, machine vision, language models, yeah, we do all that stuff. Second part, all right. Yes, the cell phones. I will say this. In certain aspects, yes. So you look at I just have to know this because I follow technology too. So the T-Mobile platform, for instance, they have their 5G signal channels that are able to communicate directly with the cell phones on down here on the LAN. But that's not my expertise, so I can't really say much more than that. But there may be someone else on the panel that might be able to go deeper. Next question. Oh,
Let me explain what has happened.
okay.
We have an abundance of information, and we were scheduled to go from 2 to 4, and just like some people had to leave early or some came in late, all our speakers have budgeted from 2 to 4. So if we could all kind of condense all this wonderful information, we would be helpful. I think our speakers would be grateful. Okay, so
Wrapping it up. Well, thank you for all your questions. I do think engineering is fun. The schooling part was challenging, so I'm not gonna sugarcoat that. It does take some mental endurance to make it through these programs. So if you keep going, I feel like most will make it through. You may have to find a tutor. You may have to take summer courses. But if you follow a plan, you'll usually get through it. But that's all I have. Thank you.
Good afternoon, everybody. All right. First thing I'll say is a lot of what we have here today was my idea. It's one of the things I wanted to do before I retired, and I told my team here, don't spread any rumors. I'm not going anywhere yet. Okay, so my name is Earl Lowe, and I am an my name's Earl Lowe. I'm a member here at Rising Sun. Born and raised in Georgia, married, I have 2 children who grew up in this church. I am a manager at Northrop Grumman. Sir Walter sits down the hall from me, and I'm a manager of space systems. Now, our company used to be called Westinghouse. They were purchased by Northrop Grumman. I've spent a 47-year career here with the company. The pictures you see on here sort of represent some of the different things that I've been able to do while at Northrop. I started out working in a lab wearing a clean suit, that's the big white garment, and testing integrated circuits. Later in my career, I moved on and I did flight tests. Sometimes we'd be flying a plane up and down the Chesapeake Bay. Other times we took it out to the desert in Arizona and tested sensors that way. My current assignment, though, is in space systems, and I have a couple of different videos I had hoped to play before or after today, or at the end of the day, where I work on the development of satellites. The one that I show here is called SBIRS. It detects missile launches. In other words, when Vladimir Putin launches a missile, we're able to tell the Ukrainians that a missile is coming. All right? So engineering has provided me with a rewarding and enjoyable career, and I hope to encourage some of our youth to pursue a career in engineering. My wife had me take out some of the details, but I have to give a little bit of homage to my parents and that they were very supportive. One of the things I got to do was go to a summer career fair at the University of Illinois. And for 6 weeks, every week, I was exposed to a different version of engineering. Mechanical one week, civil another week, electrical another week, even aviation. The University of Illinois is famous for some of the aviation simulators that they have. But that was the one thing that inspired me to keep going and to become an engineer. Now, the first 20 years of my career, I was a hands-on guy. I did design first with boards and eventually with what we call FPGAs, field programmable logic. And what that is Sir Walter talked about your cell phone or your TV, things like that all have electrical technology in there, and we have people who program that technology to do special cases. My current assignment as a functional manager, they don't let me touch the hardware as much anymore, but I still have to have the ideas. I've done things where I've gone out and recruited at colleges. I've also recruited a couple of the people who are working on this panel today. And my main job is finding work for my team. All right, I work on proposals. I do cost estimating. A customer has a function. How much is it going to cost for us to do the engineering to to support that function? But the major task I do is I'm leading and managing people. All right, I've told people that if we did not have problems, we would not have an engineering team. Engineers like to solve problems, like to solve puzzles. That's what we do. Why I'm here today, as I said, I wanted to encourage some of our youth to pursue a career in engineering. And what I do want you to do is when you go back to school and you take those classes and you go, why am I doing this? I'm never going to do this. You never know. You never know what opportunities are going to open up for you, and you want to be able to take advantage of those opportunities. 3 pictures that I put up here are, first of all, the pyramids. That engineering is one of the oldest careers in the world.
Yes.
The pyramids, you can go to Africa and look at them, but most people don't know that the pyramids were built 2,000 years before Christ. Now here we are 2,000 years after Christ, and those pyramids are still standing.
That's right.
During Christ's time, the Romans, who conquered a great portion of the world, built aqueducts. They brought waters to cities. Before that, there were problems getting clean waters to large populations. Some of these aqueducts are still standing. The middle picture, I put it in, as I said, space is the thing that I support. What I want to tell you, though, it used to be if you wanted to see something launched into space, you had to go down to Florida or out to the West Coast. This is actually over in Wallops Island, and you could be over in Ocean City and watch a satellite being launched into space. All right, engineering is the creative application of science and math principles to solve problems by designing, building, and maintaining structures, machines, and systems. That's a mouthful. All I want to say is engineering is about thinking about a problem and coming up with a practical solution. Math and science are just the tools that we use to achieve our goals on those problems. Here are 5 types of engineering. You'll get disputes when you talk to other people. I actually have another sheet that describes other types of engineers, but most engineering are derivatives of these 5 fields. The last thing, engineering, a number of people will go into engineering, but that's not their final goal. They want to do something like go into law or go into medicine. Often, if you create something, you need a patent, and a lot of your patent attorneys are engineers because they can understand what needs to be in the drawings. Biomedical, that's a big thing that's going on at both Hopkins and University of Maryland Medical School, where we're combining engineering with with either electromechanical or mechanical engineering when we're creating parts for bodies. A note I was going to say, only 5% of engineers are African American. A friend of mine, Mr. Marvin Harris, is here with me. He has a similar 48-year, right, career with me. When we started at Northrop or Westinghouse, there was a table in the cafeteria. And at lunchtime, all of the black engineers met. That tells you how few there were there at that time. It pleases my heart to say the table isn't there anymore, and that everywhere I look, every building that I look at in Northrop, there are minority engineers working in every part of the company. Wow. And with that, I believe that engineering can provide all of you a rewarding career. And with that being said,
mentoring the younger engineers when they come in, they full of enthusiasm. I like the camaraderie, the team cohesion. You know, we constantly in the innovation mode.
So I came to Northrop Grumman because I'm a mechanical engineer at heart. I love coming to work every day.
There's a lot of technical mentorship, making sure that we understand the technology, but also a lot of professional mentorship.
I'm really in charge of helping build the next generation of workforce. It's a really exciting time.
To any woman who's starting her degree in engineering, stick with it. Work hard, push yourself to succeed, but don't count yourself out.
When you enjoy what you do, you don't really have to work at it. Northrop Grumman allows you to go and be whatever you want, as long as you have the determination and the work ethic to get there. That's defining possible.
Have to do the company spiel.
Yes.
Thank you.
Okay. Okay, hey everybody. Is this necessary? Okay then. My name is Opie. I am a fellow engineer like Earl and Sir Walter. But my path is fairly unconventional. I'm also an electronics engineer. I design, among other things, I design systems that end up on planes, ships, space, and places I can't talk about. But, you know, things like that. Let's see here. So how did I know this is what I was going to do? Okay, so show of hands. Anybody ever see that movie Iron Man? Like the first one from 2008. Okay. I saw that. Changed my entire life. That's the entire story. I saw that and saw, yeah, I want to do that. And it turns out it's a real job. It's lots and lots of jobs, actually. And first of all, the pay is good. Second of all, you can actually do a lot of really cool things. And what I love the most about engineering is that if you do it at least the quote-unquote right way, you start to see lots and lots of things in the world that don't have to be the way that they are. And then gradually you start to realize that you actually have the necessary tools to change those things. If there's some appliance at your house that annoys you and it's like, why is it that way? Well, as an engineer, you can just up and decide one weekend, okay, I'm going to change that. I'm just going to design a thing and make it not do that. You can just do that. And that engineering sort of ethos, that engineering sort of mindset, I take it with me everywhere I go, and I apply it to all the problems I encounter, whether it's, you know, at work or not at work, right? Some things that you wouldn't even think are very complicated, crazy problems, things that you would think that are pretty simple, they can turn out to have a whole world of complexity. Right? So let me see if I can come up with a simple example here. Anybody got a watch? Yeah. Okay, so like a normal watch, right? Not like those, even your fancy Apple watches and whatnot. How do they keep track of time? How do they do that? It turns out when you go learn about it, you'll find that among other things inside this device, there's a little thing that we like to call crystals. They kind of wiggle. about 32,000 or so times a second, right? And then you think, okay, just kind of, now that I know that it wiggles at this speed, I can kind of divide how fast it wiggles to about a second and then use that to track time. Not too bad. But the kinds of things that we deal with at work, for example, if you take something that wiggles and throw it onto something else that wiggles, say you put that chip on, I don't know, an engine. Anyone ever put your hand on an engine when it's, on? It like vibrates, right? So that wiggle from the engine messes with the wiggle for the timekeeping. So now you have to design other systems to make sure that the wiggle from the engine doesn't mess with the wiggle of the time thing. Because if you get your time wrong, you don't know where you're going, right? And that sounds crazy, but let's say you decided to, punch something in GPS and, you want to go to, the nearest grocery store or whatever. How does your phone know where you are? It doesn't. It actually doesn't. All it does is that it asks 4 satellites that are, above your head what the time is. And then those satellites are constantly yelling what the time is. And then your phone has to then use that information to figure out where it is. It uses the time. It can't do that if it doesn't know the time, right? So very small, seemingly trivial things have worlds of complexities inside them. And that's what excites me the most about doing engineering. So when I wake up in the morning, it's not so much, oh crap, I have work to do. It's more like, I wonder what fun things I'll get to solve today, right? Or I wonder what fun things I'll get to learn about how the world itself works, That's what engineering is to me. So that's how I got into it. Let's see here. Let me now go with the script here. There's a bunch of questions. So now you know what my typical day is like, thereabout. The type of education that's needed for this career, well, it's STEM. So, you know what? Maybe not just STEM, let's just say STEAM. Because a lot of people, discount the arts, and then they consider them as a secondary, trifling annoyance. But you see, this is a hill I will die on, by the way. Engineering is not a science. That's right. Yeah, I said it. It's not a science. It's an art. Because what you do is, what the job is, you take what scientists have done. You take their work, and by the way, the job of scientists is to discover things that have always been. Your job as an engineer is to use those facts about what have always been in this universe and use those things to create things that have never been. That is the job. Okay? So engineering, I believe, personally, it's an art. And when you understand that, the world is yours. You can do anything. Okay? You can do so many things. There are so many places where there are problems that there aren't enough people who are thinking about trying to solve them. And everywhere I look, I see them every day. It's got to the point where my wife has to tell me to calm down and not solve every single problem I see. And I have to try and practice to ignore them so that I don't lose my mind. But that's what engineering is, okay? Now, the kind of education that you need to, do those kinds of things, well, you need education in, besides, the usual physics, chemistry, biology, you need education in engineering. So if you have an engineering degree, any kind of engineering degree, honestly, is sufficient for you to start to think like an engineer. And also, not to knock it, but you should also learn how to, draw, like art, because I don't know if anyone remembers what it was like around 2006, 2007 when the first iPhone came out. Before then, we were using Blackberries, right? Those things had a lot of buttons, a weird little screen. It was weird and tacky, but hey, it was the best of technology at the time. And then the iPhone came out, and everyone just went, wow. Fun fact, Google was actually working on a phone at the time that looked very similar to the BlackBerry, but then when they saw the iPhone, they scrapped everything they were working on and had to start over because everybody understood that that phone was just beautiful. right? Like, forget all the fancy technology that was inside. No. It was beautiful to hold. It's beautiful to interact with. And that's why most of you have iPhones, right? So this is just me kind of illustrating here that it's not enough to just solve the problem in a kludgy way. It has to be elegant, because the people who are going to use those things don't care about the wiggling thing underneath the, like the wiggling chip inside your phone. No. They don't care about that. Does it work? Does it work the way it's supposed to? That's what engineering is. So, any questions? Oh, I'm sorry. I didn't mean to use all that time. That's my spiel, everybody.
Thank you. Thank you so much.
Hi, everybody. My name is Amalia Janoon. Sorry. Hi, everybody. My name is Amalia Janoon. We had someone who said that she was the least qualified and probably the least likely to be here. 10 years ago, I was a secretary in an engineering company, and my boss noticed that I was demonstrating STEM aptitudes. I had never heard it, but when he described what it was, it sounded like who I was my whole life, which means I probably was an engineer, but I came from illiterate parents. And nobody recognized that I was an engineer and overlooked that. Fast forward, I completed my undergrad. I was almost done in business administration. I went on to work on a master's in data analytics. And while I was working on analytics, I had been obsessed with braids my entire life. And I recognized that hair braiding was actually pattern recognition, and I had a scientific terminology called braid theory. It changed the way I looked at science, it changed the way I looked at STEM, it changed the way I looked at myself, because I was no longer someone starting late. I was somebody who belonged there, who never had a chance. I went on to, I'm now currently a PhD student at the University of Baltimore, working, thank you, working on public administration, because I thought the problem with STEM was actually policy-based. Turns out what it needs is a bottoms-up approach. I work in risk management, so I love me my bottom-up approach to translating cultural gifts and talents into what it means to be STEM. Because our kids demonstrate STEM every day, but because we don't know what those STEM aptitudes look like my boss did, we're overlooked. And so if you buckle down and do the things that are academically, the STEM path would find you, someone in your college if you're in STEM. It sounds very generic, and I wish it's a thing I had known, but you have what it takes. There's a panel here that can answer so many questions I can do, because I've been researching it for almost 10 years, but that's my journey, and I'm so happy to hand over the mic to you today. Yes, I told you, because we have so many incredible people. Sorry, yes, ma'am. Go ahead. Yes, ma'am. Yes, ma'am. That's the work of my research. Yes. Yes, ma'am. Absolutely. Mm-hmm. Mm-hmm. Absolutely. So the aptitude test I created is actually STEM-based. So I find a place for you in STEM, because the aptitudes that are STEM are actually inherently human. I so agree with Oyemi when he said that engineering is applied arts. So our kids can demonstrate an artistic skill with a STEM aptitude, and you don't realize it. If they would allow me, absolutely. But the frameworks I built, sneak it in. Yeah. Yes, ma'am. Absolutely. Absolutely. I appreciate it. Thank you, ma'am. Any other questions? All right. Yes, ma'am.
All right, the next speaker, please.
We rolling now. All right, greetings, everyone. My name is Dr. Deanna Bailey. I'm a professor at the School of Engineering at Morgan State University. I actually see two of my students in the back that came in to join us. But my journey, I want to start with my journey, and I can't start with my journey without mentioning my mother. I'm getting ready to tell my age. In 1999, I was graduating from Woodlawn Senior High School. And in my household, you didn't have a choice as to whether or not you were going to college. You were going to college. It was about what were you going to major in. And so I told my mother I wanted to be a history major. I was going to major in African American history or Africana studies, because I am a history buff. And so my mother, having taught in Baltimore City public school system for 35 years, she said, no, baby, you're not going to be a teacher. You're not going to make no money, baby. So she brought home a magazine one day, and it listed the top 10 paying majors. And at the top of the list was computer engineering. At that particular time, Morgan State University did not have a computer engineering course, or major. They had an electrical engineering major. But Morgan was doing a lot of great things under the leadership at that time of the late Dr. Earl Richardson, who just recently passed, and the founding dean of the School of Engineering, Dr. Eugene Deloach. And so they were doing marvelous things. And my mother said, you're going to go there, right? You're going to be an engineer and you're going to go there. And I said, well, I'm good in math and science, so I think I can manage. So I followed her lead. And I'm glad that I did, because my mother had foresight that I didn't have as an 18-year-old girl. My mother knew that the future was going to be STEM. She knew it, and she put me in that position. She took me over to Morgan. We fell in love with the program, and so then I entered in the fall of 1999, graduated in 2003 with my bachelor's of science in electrical engineering. And then there was a professor there at the time, Dr. Carl White. He noticed something in me. He said, Deanna, I think that you should go for your doctor of engineering. And I said, okay. And so he said, I'll pay for it. So that gentleman, Dr. Kelsey, who came up and spoke before me, he's right. PhDs and doctoral degrees, they're free. Professors will fund you. They will bring you on. They'll fund you. They'll pay for your tuition fees. And they will also give you a stipend and pay you while you're going to school. And that is my journey. And so I teach at Morgan full time. I teach 3 core classes. I teach Introduction to Electrical Engineering. I also teach electric circuits. He talked about circuits, and when you held up the board, I said, that's a PCB board, right? And so I teach my students that in electric circuits. We talk about circuit diagrams and schematics and PCB board. The whole engineering design process is what we focus on. I also teach a class called Introduction to Electrical Engineering, Electric Circuits, and Signals and Systems. During his talk, he talked to you about signals. So I teach a class called Signals and Systems and Transformation. In addition to teaching at Morgan State, I conduct research in the area of engineering education, all right? And so my research focus is on, finding innovative and effective pedagogical practices and curriculum and learning experiences that will enhance our students' comprehension, their engagement, right? And also while affirming them intellectually and culturally. So that is what my research centers on, because there's a cultural connection between engineering that people don't talk about. There's a connection between culture and engineering that people don't talk about. And so I agree wholeheartedly with what she said. Our children are engaged in STEM every day, but they just don't know it. It's a part of our culture. It's actually a part of our cultural heritage. So I was happy on your slide when you showed the Pyramid of Giza. It was actually the Great Pyramid that you showed, the Pyramid of Khufu, because it was Black African people who created those pyramids. So engineering, or we would say STEM, is really a part of our cultural heritage that we need to reclaim, because only 5%, as he said, of engineers and scientists are Black. But then the question becomes, why? What's going on? Why are only 5% of us engaged in science and technology and engineering and mathematics? And I have been arguing literally with the American Society for Engineering Education, Frontiers in Education, even at NSBE, that there's a cultural disconnect between the engineering curriculum, traditional engineering curriculum, and our students. Our students aren't engaged, and they don't see themselves in the curriculum. A lot of the laws and theories and even epistemology, the pedagogy, is Eurocentric. And so it disengages, it causes, actually feelings of inferiority. We actually studied that. It causes feelings of inferiority within Black students, and they're just totally disengaged, because and when you look at the chapters in engineering textbooks, when you open up chapter 1, they're not highlighting, the historical and modern achievements of Black people. They're talking about the achievements of other groups of people. And so our students are sitting in the classroom wondering, well, what did my people do? Or how did we contribute to this profession? So that's a part of my research as well. In addition to teaching, I am the founder and director of Conscious Ingenuity Institute. And so I'm going to say that again, Conscious Ingenuity Institute. To learn more about it, all you have to do is visit consciousingenuity.com. So please write that down, consciousingenuity.com. And so my institution was established to provide engineering and cultural education. Because again, only 5% of us are engineers and scientists. And so we target Black youth specifically because of that. Now it's open to everybody. I don't care whether you're white, blue, purple, brown, red, Black. But we do target Black youth because Black youth typically aren't in those spaces. Let me think. Let me hurry up because I know we got a whole line of people. And within the institution also exposes students to cybersecurity, machine learning, artificial intelligence, and programming. So we offer a number of programs. All of our programs are free. I want to say that again. All of our programs are free. Just go to consciousingenuity.org to check out those programs. And we have in-person programs as well as virtual programs. Our programs are being utilized from New York literally to California. We even have the program set up in Ghana. We just recently established a partnership with schools in Cameroon. So we're not only local and national, we're also international. Let me hurry up because I know, like I said, we got a line. I know one of the other questions was, what gives you joy? Engineering engineers. That's what brings me joy, and that's what I enjoy the most about my profession, about being an engineering professor. Just knowing that I'm a part of engineering engineers. Dean DeLoach used to always talk about manufacturing engineers, but being a part of that process and developing the people that I know who are going to be there in the future, who are going to advance our society, and so that's what actually brings me joy. Lastly, how to prepare, right? How do you prepare for engineering career? I know Ms. Curl said, you don't need math. I disagree with that. He gave the definition of engineering. Engineering is the application of mathematics and science. He talked about engineering being an art, and I agree with that. But you're still utilizing mathematical and scientific principles, so you have to be proficient in math and science. It's no escaping that. He's talking about building circuits. Well, you need to have strong algebraic skills to build circuits. You have to be able to analyze those circuits using Algebra 1, Algebra 2, even calculus and differential equations. So you need to have math. So there's no I'm not trying to throw a shot at her, but she did say, oh, you don't need math. Yes, you do. If you want to design circuits, if you want to design systems, if you want to design, transmit and receive and process signals, you need to know math. And so if what I would do, and this is I'm speaking to my parents right now in the audience, in your household, make sure that your children are practicing math. There are a ton of resources. You have Khan Academy. That's on the internet. There's a professor by the name of Professor Parker, Keeler Parker. He created a YouTube platform called All This Math, right? All This Math. This is free, okay? Go to his YouTube page, subscribe to it. You also have a software. There's a software called Alex, A-L-E-K-S. My son will tell you, I put him on there every night, right? He's on Alex, so we could strengthen his math skills. So there are platforms, Alex isn't free. It's like $20. It's $20 a month. But Khan Academy, All This Math, these are free platforms to strengthen your child's math. Reading is very important. Reading is very important. You can't solve a problem if you can't read or if you can't comprehend what you're doing. Reading is very important. And I remember when I was coming up, reading was a household value. That's what we did. You had to read. So to my parents who are in the audience and my young people, I know it's easy. We're on the internet. We're on our phones and things of that nature. You're looking at tweets and all that. Take some time out to read, whether it's a nonfiction or fiction. Read. We have to really reinstate that in the community. I remember when I was younger and Kirk Smoke was the mayor, it was Baltimore was the city that reads. And you don't see that push anymore, right? And so we have to get back to that. So reading, math, and also writing. Engineers write a lot. We write a lot. We have to write up our findings, right? We have to convey our findings, to our employees. So just reading, writing, and math is something that you can do in the household to prepare for an engineering career. Last thing I want to say is this. There are a lot of STEM programs that are free of charge. Please make sure, parents, that you get your children involved in those programs. Conscious Ingenuity is one of them, consciousingenuity.org. I know that's a shameless plug, consciousingenuity.org. Free engineering programs. So during the summer, make sure that your child is engaged in engineering programs. All right, a lot of them are out there for free. It seems like, and I just want to say this before I go, within our community, the line is around the door for football camps and basketball camps. And then when we're sitting here saying, hey, get your child in a free engineering program, we're struggling to get participants. Okay, and that shouldn't be. But that's all I have. Does anyone have any questions before I sit down? I know that was a mouthful. Yes, ma'am.
Do you have a card with your website.com, whatever it is? Is it written somewhere?
I don't have it written, but I can give it to you. Anybody that wants my telephone number, my number is 443. This is my cell number. Parents call me all the time. They either inbox me on Instagram, or they inbox me on Facebook, or they're emailing me. But my telephone number is 443-721-8491. I'm going to repeat it again, 443-721-8491. My email address is my name, Deanna, DEANNA, .Bailey, BAILEY, @morgan.edu. I'm going to say that one more time. Y'all probably say that's the professor in her. Got to be repetitive. DEANNA, .Bailey, BAILEY, @morgan.edu. Thank you so much.
Hi, everybody. Good afternoon. My name is Morgan Jones. I'm not going to go into much detail. I'm from Cleveland, Ohio, originally. I'm the vice president for the National Society of Black Engineers, Baltimore Metropolitan Area Professional Chapter. A little bit about myself. I am from Cleveland, so that's in Ohio. I've been a part of NSBE. I mean, you're hearing a lot about NSBE. I've been a part of NSBE since high school. My mother put me and my sisters in it, and through that program is where I fell in love with engineering and why I'm here today. I also work at Northrop Grumman. Yeah, I do. I work at Northrop Grumman. I am associate systems engineer. I'm a Pathways, so that's a rotational program within Northrop Grumman where early careers could rotate and find what discipline of engineering they want to be in. Let me take a few steps back. I got my bachelor's in science and software engineering at Miami University. No association with the one in Florida. There's one in Ohio. And I also wanted to make notes. I am a first-generational student. My father went to the military, he went to the Army, and my mother has her associate degree. And I also have a learning disability. I'm dyslexic. And the reason why I say that is because it is possible for you to be in this career with anything that you are. Like, thank you. So yeah, it's possible. It's like, even like being a person of color, it's possible. Being a woman, it's possible. Yeah, I wish I could go more in detail, but I could go a little bit more in detail with my NSBE background. So I was in NSBE Junior. I was the secretary For my NSBE Junior chapter, I went to a convention there. My NSBE Junior advisor snuck me into the career fair, showed me around, told me why engineering is important, showed me the different jobs. From there, I made sure to find a school with the NSBE chapter because there's not that many of us, Black people, but then there's not that many women either, and there's not that many Black women. So I made sure to go to a school with a NSBE chapter, with a solid, active NSBE chapter. And then I knew after graduating I needed to find a NSBE professional chapter. Shout out to my parents and my grandparents. They supported me. My parents made sure me and my sisters was involved. They knew getting our higher education was important. My sister want to be a doctor, and I have a younger sister now. She don't know what she wants to do, but because of their labor and everything they did, they have a daughter in engineering and now a daughter trying to be a doctor. And I could tell you more about the programs that they put me in besides NSBE Junior, but I want to give the next speaker a chance to talk.
Hey everyone, my name is Zaina. Me and Morgan are basically kind of the same thing, except for we just have different engineering backgrounds. I have a Bachelor of Science in Mechanical Engineering. I also went to Miami University of Ohio. I'm actually currently the National Society of Black Engineer Baltimore chapter president as well. She serves as my VP. What else? I also work at Northrop. I work as an associate manufacturing engineer. Recently just changed my role into manufacturing. I'm also part of the Pathway program as well. I guess a typical day for me in my engineering role looks like go to the office, eat my yogurt, look at my emails, and then I make my way to the manufacturing floor where I talked with a lot of the operators and technicians as well. So I'm really involved with them and helping them with what they need to do. Going back to NSBE, I was also part of my NSBE chapter as well. I served as the vice president and a senator and the public relations chair alongside with Morgan. And within that role, I feel like that role helped me feel better about myself because at my university, it's very white. So I was, essentially, I was the only Black woman who's in mechanical engineering at the time, so I felt really out of place. I felt like I wasn't myself. I felt like I was doing the wrong thing. But I stuck to the plan. And I stuck to the plan, and I finished it out, and I got my Bachelor of Science in Mechanical Engineering, and I'm also from Ohio as well. So I've only been living in Maryland for about a year and some change, and I love it over here. And I feel like one of my biggest advice, because I wasn't an orientation leader in college, one of the biggest things I told students was to learn how to advocate for yourself in whatever capacity that looks like. Right. Closed mouths don't get fed. If you need help, you have to ask for help, because I feel like in high school, they kind of, we know you need help. College, they're not looking for you, but you could go look for them, and they will help you, especially professors. I love my professors. I was always in their office hours. I always talked to them. This one time I didn't do too hot on an exam, and I had to ask for a professor. I was like, oh my God, I didn't do too well. She was like, that's okay, girl. Here's the exam. Go redo it, and then come back. And ever since then, we've been like this. So, talking to your professors is very important. Being involved on campus is also very important. I also was part of my sorority, Zeta Phi Beta Sorority Incorporated, where I also served as a vice president as well, and I was heavily involved on campus. I was so fortunate to be around a lot of, Black women who was leaders on campus, and they helped me get to where I needed to be. I'm also a first-gen student. I'm the first person in my family to go to college, complete college, and then work in the professional world as well. So with doing all of that, I feel like I give myself an example. I'm big example for my 3 little sisters who's pursuing what they want to do with their lives. And yeah, you gotta kind of always believe in yourself. I also have a learning disability that I did not know I had until I came to college, because I told myself I had someone who was helping me, and I was like, I'm struggling so much. Why is that? She said, let's go get you tested. She got me tested, and I ended up having a learning disability. Mind you, I went all my school having a learning disability, and I had no idea. So that's why it's so important to properly advocate for yourself and what you want to do. One thing I love about my career, especially working at Northrop, everybody is so nice at Northrop. It's crazy. I was not expecting. The managers are so helpful. They love talking about themselves and what they do, and they love being helpful to young engineers. They want us to strive because we are the future of the company, so it's very important that they pour it into us. But yeah, don't be afraid to speak, because I'm very introverted. I don't like to talk or publicly speak, but here I am. So you gotta do things you don't like. One more thing before I go: if you find yourself comfortable, you're not challenging yourself enough. You have to be uncomfortable in order to grow. But yeah.
So you're doing it right.
Take this one.
Oh, it's on now.
No.
Hi, I'm Bruce Montgomery with the Nuclear Energy Institute. I'm glad I'm not the only gray-haired person here, so I'm feeling at home. I work for the Nuclear Energy Institute. We're a policy outfit in Washington, D.C., and we represent all of the folks who run nuclear reactors to make electricity, all the universities with nuclear programs, and all the companies that make parts and services to support our industry. And I'm glad to see the young folks here, because the first most important step towards a successful career in engineering is to say, I want to find out more about it, and you're here, and so you're in the right place. I'm not going to tell you what it takes to be an engineer, because you've heard that several times already. I'm just going to tell you about my industry and why it's so cool. And Earl, you had a list of engineers up there, and you said, I think you're missing one. That's nuclear, okay? Nuclear, all right. So I'm not going to tell you much about my day at Nuclear Energy Institute, because it's a policy outfit, and we work with Congress and the White House and Department of Energy, Department of Defense, and all these guys. I want to talk about the journey I took to get here. My mom's from Brazil, my dad's from Canada. I'm first generation American. 6 kids. I was the second one of those, and we didn't have much money. My father was in a union. My mother was working the candy counter at Sears and Roebuck. Does anybody remember Sears and Roebuck? Okay. My father said, I'll do what I can to help you, son, if you want to go to college, but it's kind of code for I'm on my own. And so I was a nerdy, techie, science kind of guy in high school. And I always knew, my father was in the Merchant Marine during World War II. So I knew I wanted to go to sea, just sort of cool stories he would tell me. But I was kind of a sciencey, physically, tech kind of guy. So I decided I wanted to go to college, but I had to find a way to get there for free. So I got into the Naval Academy, because in high school I worked on sports, I worked on my AP physics, and all the different things you want to do. I tried to do good in math. I wasn't really good at math, but I got grades good enough to get accepted to the Naval Academy. Got to the Naval Academy and came out with a degree in marine engineering. Now, marine engineering is what makes ships go, right? All different types of propulsion systems, including nuclear. And when I got out of the Navy, I decided I wanted to go into commercial nuclear power, which is what I did. I went to, first off, I was born and raised in Miami, Florida. Miami, not Ohio. And ended up here on the Chesapeake Bay, which is a beautiful place to be. I just can't imagine a nicer place to live. I live on the water down in Chesapeake Beach. And so I came up, started working for Bechtel Power Corporation. And one thing about the nuclear industry is you don't have that many nuclear engineers in the industry. You have civil engineers, all the ones on your list, Earl, plus architects, okay? So we have every kind of engineer. It takes a lot to build a large 1,000 megawatt nuclear power plant. It takes a lot to build a small modular reactor. All of the disciplines have to get together to figure out how to site it, how to design the core of the reactor, how to build the plant around the core to make it generate electricity. So there's just so much going on there. And this industry is really taking off. We have a shortage coming up in electricity supplies. The Mid-Atlantic region is going to be coming up short, I think, in the next few years. Has anyone noticed their electrical rates going up? Okay, that's just supply and demand. So we need to put more supply onto the grid. We need clean, carbon-free power. It's got to be there 24/7. It's got to be reliable. It's got to be in the long run. It's got to be affordable. Now, that's going to be nuclear. mostly. There's going to be some complementary solar and wind and whatnot, but mostly nuclear. I worked for Baltimore Gas Electric Company for years down here. We wanted, I worked or was associated with Calvert Cliffs Nuclear Power Plant. A little bit more about that in a minute, but we wanted to build a nuclear plant up at Aberdeen Proving Grounds to supply the grid north of Baltimore. We couldn't get permits for it. 3 Mile Island happened, a lot of things happened, got too expensive, not politically acceptable. It's becoming more politically acceptable now. So after Baltimore Gas Electric Company, I joined Constellation Energy, actually sort of like emerged from Baltimore Gas Electric. I got sent down to Calvert Cliffs, worked there a ton of years, ended up being the chief engineer at the Calvert Cliffs Nuclear Power Plant. Got sent up north to the 9 Mile Point Nuclear Power Plant when we bought that facility, 2 reactors up there as well. Came back to Calvert Cliffs, spent the rest of my career there and also in corporate here in Baltimore. We really need to find new folks coming into engineering, all different disciplines, to design and build these plants and to operate them. So typical day at a nuclear power plant as an engineer, if you're a design engineer, you're working on the modifications for the next refueling outage that can go in and replace obsolete components. If you're a systems engineer, you're going into the plant every day to make sure your assigned systems are working smoothly. You're talking to the operations crews, what happened last night, how are things going, what is it you want me to work on today, and then also make sure you have a long-range plan to upgrade those systems to keep these plants operating. So Calvert Cliffs, for example, went into operation in the early to mid-70s. It's going to be continued operating for at least 80 years. And there's thinking now that these plants can actually operate for 100 years because we take care of them. We operate them with a lot of care. We replace a lot of equipment, upgrade the equipment, renew the equipment, and so forth. So these power plants are just really becoming more and more central to our economy. And we want power that's carbon free. And so I'm just telling you, if you're looking for work, and if for some reason you're inclined for another line of work, the one thing, several things that we need the most are craft. If you want to learn how to weld, if you want to learn how to pull high voltage cabling, be a high voltage electrician, low voltage electrician, electronics, we need all sorts of people. We certainly need civil engineers and all the engineers on your list. So I'm going to be around. I'm not going anywhere real quick, so I'm going to be around. I've got some trinkets over here. I've got a video I could play later on. But I just wanted to get the message out to you that our industry is growing. Baltimore Gas Electric Company, Constellation, which is local now in Fells Harbor, or down in the Inner Harbor. We're going to be building more reactors. I'd like to see one go up at Calvert Cliffs. We've got 2,700 acres there, plenty of room to put another reactor or two. And the coal plants that have been shutting down in the region, we'll probably be replacing those with new, clean nuclear. So the future's bright. Thanks.
And I put up a more extensive list that has nuclear engineering.
And I have a PowerPoint. I'll try to be really, really brief. Hi, everyone. My name's Leslie Tillman. I am also a civil engineer, so I don't need to go into details about that. Miss Judith from Carroll Engineering gave a really good overview with all those project pictures. There you go. Yes. Awesome. So I'm also representing the American Society of Civil Engineers. We have a local Maryland section, and within our section, we have a younger member group, which is specific for folks who are 35 years or younger, including students, any high school or college students. So I'm the president of, there we are. I'm the president of our younger member group. So we have a website. ASCE is a national organization with tons of resources, so definitely check out the website. I wanted to highlight the fact that civil engineering is so broad. You can do all types of civil engineering. So I do the same thing that Judith does, site or land development work, but there's also construction, geotechnical, utilities, transportation systems. What else is up here? Architectural engineering. So that would be like a mix of architecture, engineering, structures. Yep. So here's some pictures of me. I work at Daft McCune Walker. We just call ourselves DMW. I'm a civil engineer. There's me walking around the construction site, which happens sometimes. There's me at my desk. I'm working in AutoCAD Civil 3D. So that's a popular software if you're interested in using the computer, drafting, drawing, designing. It's all on the computer, modeling. So the company I work for does planning, architecture, landscape architecture, environmental services if you care about the wetlands, if you care about the trees, the forests, what's going to happen if we start to develop our land. That's why we have an environmental department inside our civil engineering company. Also surveying. I got my bachelor's in civil and environmental engineering at College Park. I also have my professional engineering license. That's very important. But besides being a civil engineer with an engineering degree, there are other paths to working at a civil engineering company. So I would encourage you to also check out community college. There are programs that are, for example, engineering technology would be an associate's degree. You can transfer to a 4-year university with a civil engineering program. You could get certified in the computer-aided design software. You could be something like a GIS specialist, or someone more administrative, doing project management, project coordinator. I think the rest of my slides are just some project examples from DMW, so happy to share later. But all kinds of things, commercial. Let me see if there's something local. Well, all these projects are probably in Baltimore and Howard County. This is Merriweather concert venue. Port Covington is now called Baltimore Peninsula. We do all kinds of healthcare buildings, including Shepherd Pratt, Towson Square. This is the Cinemark movie theater in downtown Towson. Bunch of retirement communities. Some more healthcare. Kaiser Permanente, GBMC, University of Maryland Medical System. And I don't see Morgan College. I feel like we have some Morgan projects. Several different education, elementary schools, high schools. A typical day for me, you can read this at your leisure. I'm designing on the computer in AutoCAD. I'm checking out my construction projects in the field, answering construction questions, and doing computation reports. So a little bit of everything, but that's just a little bit about me, and I'm happy to stay later and pass it on to the next person. Email is ltillman, LTILLMAN, at ascemd.org. I have business cards too, so. Thank you, everyone.
My takeaway, actually, can you hear me? Yeah. So first I wanted to thank everyone who obviously has stuck it out for over the 2 hours. But my takeaway from the fact that we have gone a little over, and as I've heard everybody speak, I hope it's very clear that we all love what we do. I think that was my takeaway, because I'm an electrical engineer. I'll talk a little bit about that, but I learned a lot about civil engineering. My brother-in-law is one. I kind of thought what he did was boring, but today I'm thinking, wow, this is really cool. Civil engineering is really cool. My dad was a mechanical engineer, and actually me growing up, I said, I'm never doing what my dad's going to do. That's why I'm not a mechanical engineer. But actually, I've come to learn just through my own career, mechanical engineering is a really interesting field as well. I do electrical/computer engineering, kind of, in that broad field. Clearly, I enjoy that. Nuclear engineering, I've heard about. So just from the enthusiasm, the fact that clearly we can all go on and on and on talking about what we do day to day, hopefully shows you that what we do is something worth doing, and we really, really enjoy it. Opie mentioned how it never feels like work. I would say that is exactly true. When I wake up in the morning, in my bed, I'm kind of thinking about, oh, what did I leave yesterday that I couldn't figure out? What do I need to do to try to figure out this? Who am I going to talk to? What should I start researching? How can I figure out this tough problem? And that's how I start my morning. That's what I'm thinking about when I'm in the shower. Earl is my manager at Northrop. I will say this, and Opie is just around the corner from me. They often see me randomly wandering the halls. I think they know, both of them know this. I'm always walking around. It's not random. It's because so much of my day is thinking, because I'm trying to solve these problems. So I'm not really stuck at my desk. I mean, I'm at my desk when I'm trying to maybe put forth the whatever problem I have solved, the solution into the computer, into the drawing, into the program. But so much of my day is spent trying to figure out these really tough problems that I often go around walking. For me, it helps me think, but also just tells you that I'm thinking when I just first wake up. I'm thinking when I'm in my shower. I'm thinking when I'm cooking dinner. And engineering is great because I'm constantly thinking about really new things and tough problems. And that, for me, is actually one of the biggest things that I enjoy. So, but kind of going quickly through my slides, my name is Shahana. And the first slide, let's see. There were everything. Yeah, there you go. Yeah, so I'm, as I said, yeah, there. Yeah, right. Oh, sure, I can do that. I can do that. That works too. Is there the, okay, cool. So my name is Shahana, and I work at Northrop Grumman. And actually, I've only been at Northrop Grumman for a little over a year. Before that, and that picture right there is taken at Goddard Space Flight Center, because that was where I called my work home for 21 years before I came to Northrop. So yeah, I'm an electrical engineer there. I'm an electrical engineer, obviously, at Northrop Grumman as well. Before that, I worked at Hughes Network Systems, which is a telecommunications engineering company up in Germantown. So that's kind of my career. So I was actually, a little bit about my background. Again, a lot of people have spoken about just engineering in general, and I can get into that more a little later, but a little bit more maybe of my background. I was born in the US, and what happened when I was 6 years old, my parents, they were immigrants from Bangladesh. So my father actually came here in 1952 to do his master's. He came apparently by ship. That was still a thing. He came through Ellis Island, but when he worked for the Naval Research Lab. He was a mechanical engineer. He was the first generation immigrant. I'm the first generation of the family born in this country, so I'm a born U.S. citizen, but I actually grew up in Bangladesh. So from the age of 6 to 21, I grew up in a different country. My education was completely in a different country, and then I came here for engineering school. So that was kind of my background. Went to the University of Maryland to do my engineering degree. Place where my dad did his PhD in the 70s, actually. And I did my master's from Johns Hopkins. And I know some other folks also spoke about math and sciences. I think that's a common theme that has been spoken of here. And yes, my father was really, really big on, I think it was you who was saying to practice the math skills. My dad was, oh yeah, I knew it was one of you, right? Was talking about practicing the math skills. And I remember my dad, even when I was in first grade, second grade, he always had flashcards with him. I remember that really vividly, that wherever we went in drives, he had a set of flashcards, and that was something that stuck with me. So being good at math was something that my father really, really motivated us to be, all of my siblings. Reading was a thing, and my father actually Again, going back a little bit to my family background, he came from a family in Bangladesh that were illiterate. They lived in a village somewhere. His parents did not have education of any kind. And so him growing up, I mean, honestly, I don't know how he got himself an education. He pretty much got himself an education, but he never had the opportunity to read in that way. I mean, he went to school, he put himself through college. But when we were growing up, he would say, you know, I'm not going to buy you this, that, and the other, right? You know, if you go somewhere, you can get one toy or whatever the case may be. But he would always say to us that, but if you want to read a book, there's no limit. If you finish one, I'll buy you another. And so that was one thing that also really, really stuck with me. So I absolutely agree. The math, the sciences, and the reading, actually, is, you know, we do engineering, but reading and writing skills, knowing how to read and comprehend what you're reading, to really focus and pull that information out of what you're reading, I think is really important. I think we're really, really losing today, and it really, really disturbs me sometimes when I see that. You know, it's just, you know, being able to read a long-form article and pull together your own conclusions from what you've just read is really important. I think we're moving away from that and just getting other people's opinions all the time. So that's one thing. So I was very lucky. Like I said, I grew up in Bangladesh, but I was really lucky because, you know, Bangladesh is not a very rich country, of course. It's a very poor country. 90% of the population is, you know, under the poverty line. They're mostly illiterate and so forth. So I was actually really lucky where I grew up that I went to one of the top competitive high schools for girls in Bangladesh. And so that was, I think, it really set a work ethic for myself, and it also put me in contact with a lot of very highly motivated girls, which was really, really instrumental for me. And pretty much all the girls from my high school I know have gone off to have really good careers in all kinds of fields, not just engineering, but they've become medical doctors, economists, you name it. So I think that for me was a really good foundation to have gone and done my high school in Bangladesh. I think that really taught me my work ethic, organization, and time management skills, which is also, again, you need the math and the sciences, but honestly, I feel like having organizational skills is really important. Being able to manage your time to figure out, you know, how do you seek out the answers that you don't have, because in engineering, most of your day is spent trying to do things that have never been done before. So you really need to have the skills to not just know how to do something, but know how to figure out how to do something no one else has ever done. Because that is probably, 80+% of your day-to-day as an engineer is figuring out something for the very first time. So my chosen career path is, so I work in, I think a couple other folks have already spoken about the engineering side of it. I'm in electrical engineering. More specifically, I work in digital design. I do printed circuit cards. I know a couple of folks have already spoken about that. And I also do programmable logic arrays. So I kind of specialize in both kinds of fields in the digital domain. So that is kind of my area. I have actually, later on for some time, I have some circuit cards and stuff over there we can look at. And the thing for me, actually, when I was going to college, and it's like when you go to college, I had sort of a general idea. I wanted to be an engineer, sure. Electrical, mainly because my father was mechanical, I'll be honest. That was why I went into electrical. But one class in particular that I really enjoyed taking in my junior year in college was where I got to do something hands-on. And it was a programming class, and I had taken some programming classes, but most of those classes where I wrote a program, stuff printed out on the screen, and I was like, yeah, okay, fine. But then I took a class where the professor was he was a part-time professor, so he worked out in industry, and I think his outlook and the way he taught was different because of that. And I remember that one of the things that I really enjoyed in that class was figuring out how to make an LED blink. And at that point, I fell in love with the tangible nature of hardware design. And that's kind of why I got into that chosen career path. I started out telecommunications and Hughes Network Systems. And I went on after that to work for NASA. So that was an opportunity that I'm so glad I had. And it turned out the first thing I worked on when I went to NASA was the James Webb Space Telescope. And maybe some of you have heard about that, but a little bit, that's great. And I cannot I'm not going to lie, I have to say, working on that is probably the highlight of my career. So that was, not just because of the engineering aspects of it. Actually, one of the things that I really, really liked about working on web was just the scale of the program allowed me to work with people from, obviously within NASA and within Goddard, but more so across different companies, different organizations, different countries, different continents. And I just found that whole coming together of that collaborative nature of engineering was maybe just the most fun thing that I have ever done. So that's a picture. Actually, I'm in that crowd, and that is a picture where the scale model of JWST came over to Goddard, and I actually remember taking this picture. It's funny, when I took that picture, this was in 2005-ish, I think. I didn't realize how much this picture would get passed around. Now, you just Google web, and that one always comes up. So and I can always zoom in and find myself, which is funny. So yeah, that was interesting. But I've also worked on some other space missions over the years in my time at Goddard. This lists some of the ones. RST is Roman Space Telescope, which is the next one. It's supposed to launch next year, so I'm excited about that. Hopefully going up. And yeah, and I've done some other projects that I've been really fortunate to work on. So a day in my life, this is actually a picture of PACE, which is another satellite that launched in 2024, climbing satellite. But you know, a day in the life, and like I said, design circuit cards, there's a lot of programming involved, there's CAD software, a lot of interesting tools, simulation tools, and all of that is there. But I think really as an engineer, the thing that's most interesting to me is the collaborative stuff that goes on. One of the things, like because I left, 20 years at Goddard, I was very comfortable. Obviously, I liked the people there, I liked the environment there, and yeah, I wasn't planning to leave. It just worked out that I left, and I ended up at Northrop. But one of the things that actually is surprising to me and enjoyable to me is that while I didn't necessarily want to switch, but I did. But by switching, the new people that I've come across, like the new ideas and learning a lot of the new things at Northrop, has actually made me a lot more excited again, because it's like, that's really the part of engineering that I enjoy most, is sitting in a room filled with just blazingly intelligent people and constantly learning something new from them. And that's the part that I like most about my day, actually, is just, learning something new, either, through using a new software tool, but more so learning something new just from the people that I talk to. I think that's the most fun for every day. And it's just, like I said, it's just really neat to work with so many interesting and talented people from all over the world. That's the cool part. So what can you do? And I know a lot of people have already spoken about that, right? Are you interested in math and science? Definitely nurture that. That is definitely something that you can't go wrong. And I'll go back to my father again, because these are things that he had said to me when I was young that really stuck with me. And he said, if you're good at math, you can pretty much do anything. You don't have to necessarily do something specific to math, but if that's a skill that you cultivate, that opens up paths in your brain that allows you to really do anything you want. And I agree with him, actually. I think that really is a foundational skill, that and reading. So definitely that. I know other people have spoken about finding STEM opportunities, things like camps, programming classes, internships, volunteers. Start at the middle school level, certainly high school and college. What's great nowadays is all the free resources online, so I think that's really cool. See if you can find somebody in your neighborhood, in your acquaintance space, in a field that you might be interested in, and just offer yourself to shadow them for a little bit, right? And see if you can learn from them that way. Most people like myself, we'd like to talk about what we do. I think it's clear. We keep going on and on. We just don't stop. But so I think, one of the things that children I've seen, at least through my own children, is they seem to always feel intimidated to approach somebody to ask a question. What they don't realize is that when a kid comes to us and asks us a question, it makes our day. Like, it really, really does. So, if you think you might be interested, go up and find somebody, ask them about it. And I can guarantee you 10 times out of 10, they will want to show you more what they do, right? And they will take the time to do so, because like I think we've all been saying, we really want more children to really find an interest in these career paths because for all of us, it's made a huge difference in our lives. And you know, we're start early, you know, middle school, elementary school is not early enough, or not too early, I should say. And you know, we're really lucky that we do live in an area with a lot of tech companies and a lot of opportunities, both learning-wise and work-wise, so I think that's really cool. I think that might be it as far as my slides go. So thank you again. I do have some stuff over there. If anybody wants to stop by, I have an infrared camera. I was around to talk about web a little bit, so I'm happy to do that.
Okay, I guess I get to be the anchor. My talk will be quick. I'm going to talk about engineering is a series of decisions and choices. Back when I was in 8th grade, I wrote an autobiography. I said I wanted to be an engineer, but I was thinking about driving trains. I had no idea what electrical engineering or anything was. So when I chose college, it was like because my father said you're either going to work or go to the military. I didn't want to do either one of those two things, so I went to college. So I'm an electrical engineer at Northrop Grumman. I started in 1977, and I was on then they call it the graduate student program. Now they call it Pathways. And you was only supposed to do a 1-month assignment, and it moved to another assignment. I did it for 2 years. Because I couldn't make up my mind. I finally went permanent with the position, the first assignment I took. So my whole career has been deciding what I wasn't going to do and then getting opportunities to do things that pushed me in that direction. So when I started college, about the time I got ready to graduate from college, they said engineers wasn't getting jobs. They wasn't hiring engineers. I said, bummer, I picked a career. I might not can get a job. Then I did some job interviews in my senior year, and I chose Westinghouse back then because I could work in a lab and not have to wear a tie. So that's choices. I chose not to wear a tie, so I took a job so I could work in the lab. So once I got in the lab, I really enjoyed it. I liked testing and working with parts and keep my hands on things. That was what I was really good at. And I got real good at programming tests too. And about the time when I started, computers were new. So we didn't really have computers. And when we did, the older guys didn't want to fool with them. And so they say, well, here, you go play with it. And they let me play with it. And so that's what I did. So I did that for 16 years. And I did automated testing, and I got real good at that. Then I got laid off from a job that I never worked on, which was a series of decisions and things that happened to you. So I got laid off, but I got picked up by this other down in Annapolis. So now I work down at the Bay Bridge, near the Bay Bridge. Beautiful sight. You know, you get to watch the water, get to see the hurricanes come across the ocean. But anyway, so I got picked up down there, and I got also, before I got laid off, I avoided getting a clearance, a top secret clearance. I didn't want one. I didn't want to go through all the paperwork and all that stuff. But when I went down there, I had to have one. So I had to go to the paperwork and do all that stuff. So for the next 20 years or 15 years, somewhere around in there, I worked in the classified world. So I can't talk about what I did because I can't talk about what I did. But before I got laid off, I did work on the F-16 radar. Anybody know the F-16 fighter jet? I worked on the radar for that. There was a radar they put in a tank called DIVAD. I worked on that. And right around the time I got laid off, the Apache helicopter, anybody heard of that? So I worked on the longbow radar for that. So that's what I was working on when I got laid off. Since then, I've worked in the classified world for a long time. And then something happened. My program got canceled. And then I got to come out into the real world with all the rest of the engineers. And then my job, didn't think they wanted to do anything with me. So I ended up not doing anything for a couple of years. And then now I'm a purchaser, which is far away from being an electrical engineer. So now, but they gave me a credit card. So I get, and they gave me a cell phone. So I got a cell phone and credit card, and all this is company stuff. So I get to buy stuff for other engineers. So that's what I do. So because of that, I became an expert at Excel programming because you got to keep track of all this data and stuff like that, keep track of the money and stuff like that. So that's what I got real good at. But also, I call engineering a gateway career because although I was an engineer, my passion was music. So I've been playing music since 1979, which is the reason why I was late today, because I was at rehearsal. So I had to hurry up from rehearsal, come here. So currently I'm in 2 bands and kind of starting a 3rd band. So that's kind of what I do. And, engineering, because of that, it allowed me to understand the new technology that's going on with music, a lot of the new equipment that came out. I'm also work with the media at my church, so I do all the lighting and the camera and all that kind of stuff. I'm head all of that. So that's pretty much my story. Anybody got any questions? Ooh, good. Ooh, good. Thank you very much.
Thank you all.
I just want to say thank you to everyone. This has just been an exciting day for me to see so many people who were willing to spend their Saturday with us to share information with parents, youth, and other caring adults. And I want to thank all of you for coming.
Okay, can I take 1 minute? All right. Once again, I also want to thank all of you for coming. And by the way, Shahina says Earl, and I know most of you who know me as Brother Lowe. but some of the people have been influential in having them come to Northrop, and I appreciate them taking the time to come here today and support this ministry of career exploration for the youth. I'm especially happy to see more youth coming out to events like this. We all care about you, and we want you all to have rewarding lives. And with that, please bow your heads. Yes.
I'm here to speak on behalf of the pastor.
Oh, okay. Come on up. Mm-hmm.
On behalf of the pastor, I'm Thomas Savage. I'm assistant pastor here, and we want to thank all of you, especially your presentations. It's so beautiful and so insightful. We thank you for coming. Right now, I'm understanding that in a year, Owings Mills will have, because of nuclear, your work out there, that you're going to get, we'll get free electricity in Owings Mills. So you'll see to that.
When I get it, then you get it.
Okay. And anybody remember Jackie Wilson? Mr. Excitement. And Dr. Bailey, one thing you said, what my parents told us when we were very young, my mother said we had to go to the library every Thursday. And my father stood there and said, well, you have to get 3 books, and they all must be read. And I was the one that was always sarcastic. I really wanted to say to him when I got back from the library, Daddy, I couldn't find any red books. But I knew better. But what I did do, I came back with 2 books and Boys Life magazine. I don't know if anybody remember that. My father told me, go back, that's not a book. But I thank you all for coming. We thank you, Sister Blunt, for blessing us with this ministry, and we are just so grateful. So let us close with a word of prayer. Father, we thank you for this gathering. We thank you for this ministry. And we thank you for those who will sacrifice their time to come out and share with these young people. So, God, we ask that you will continue to bless us. In the precious name of Jesus, we pray. Amen.
Amen. And with that, we're all dismissed. Thank you all again.